Welcome everyone. Azure AI Connect 2025. We're continuing strong. Day 4 actually, and we have with us Dennis, if I'm pronouncing correctly, Dennis Torres. He's going to explain everything about Azure SQL and OpenAI using Transact SQL, TSQL. It's the first time I'm meeting Dennis. Let me add him to the stage. Welcome, my friend. It's so nice to meet you.
Hello, nice to meet you, Konstantinos.
Yes, first of all, thank you so much for being with us today. It is really an honor for us to have you here. In reality, it's the first time we meet, and I'm sure you have a very exciting session to start our day with. So I'm going to leave the stage on you. I'm sharing also your screen to the stage, and you are in the driver's seat. Welcome, everyone. Dennis Torres is with us today.
Thank you very much, Konstantinos. It's a pleasure to be talking on this conference. Today we'll talk about Azure SQL and OpenAI using T-SQL. How to use the OpenAI power using T-SQL from an Azure SQL. So, this is me. I'm a former data platform MVP, work for the Tower Software and Onyx Data, and I'm the leader of Malta Data Platform User Group. I live in Malta. I'm a trainer with many Microsoft certifications, and in the right side of the screen, you can see my contacts. It will be a pleasure to connect and stay in touch. Connect on LinkedIn, YouTube, stay in touch. If you have any further questions to send later, it will be a pleasure to stay in touch. So, first, let's talk a bit about OpenAI. I believe most of you already have had some contact with Azure OpenAI, but let's see a bit of it and the main points related to this session. Azure OpenAI, I'm not talking about the OpenAI, the company and the services it provided by itself. I'm talking about the service provided inside Azure, which is provided by this company as well. It's a service provided inside Azure. It's accessible through APIs. So we provision the service on Azure, and then when we want to use the power of the models in Azure OpenAI, we make API calls to use it. We use JSON as communication on these APIs. We make JSON inputs and JSON outputs to communicate with the APIs. In the past, we were using the Azure OpenAI Studio. It was common to use the Azure OpenAI Studio. But recently, mostly from last Ignite, Microsoft is replacing it using the Azure AI Foundry. Azure AI Foundry is concentrating all AI features in Azure, including the Azure OpenAI. We need to deploy a model. Once we provision the resource, the OpenAI resource on Azure, we need to make a deployment of a model inside this resource. And the model is what we will be using, is what we need to access through the APIs. So let's take a short look on it. So I have here my Azure tenant, and I already have an Azure OpenAI, sorry, an Azure OpenAI service deployed. The service itself only manages the security, monitoring, and so on. When I want actually to execute something, I need to go into a studio, which before was OpenAI Studio, and now is the Azure AI Foundry portal, which I already have here open. So this is the Azure AI Foundry portal. And here I can play with my OpenAI resource. I need to make deployments. I told that I need to make deployments. I need to deploy a model. For example, GPT 3.5, GPT-4. I need to choose a model and make the deployment of a model. In this example, I already had a model deployed here, and this is okay for the example that you make. So I'm using this model Lake. I can make small tests on the model here using the chat area. Usually, we give a detailed system prompt for the OpenAI, for the model itself, explaining what the model will do. And then we'll make questions to the model to test if the model is doing the task that we want. But in our example, using OpenAI from T-SQL, we will send the system prompt from the SQL, the SQL server. Here I will only make a silly example. For example, could you list the Harry Potter movies and who dies in each one? This is a knowledge that the model already has in it according to this his initial training. I don't need to add any information to get this kind of information, this kind of public information. Okay, now we need to start thinking about calling this from Azure SQL. Let's get back to our PowerPoint. So Azure SQL and API calls. We will use API to call OpenAI. So the basis for this to be possible is that Azure SQL needs to be capable to make API calls. How Azure SQL makes API calls? The point is it can. It's a feature that has been released some time ago, but considering how long ago it was released, we can consider this feature a baby. If it has 1 year, it's already a lot. Is a stop procedure called SP invoke external REST endpoint. Using this stop procedure, we can make an external API call from inside Azure SQL. External API calls from T-SQL requires a credential object. Of course, access like OpenAI on Azure will require an authentication, so we need to authenticate against that server. In this case, for the authentication process, we create a credential object inside Azure SQL. And then we can use this feature to call the OpenAI service. We can use the SP invoke external REST endpoint to make the call to the OpenAI service. This stop procedure only calls Azure URLs. You can't call anything outside Azure. It's a matter of security. There is a workaround in case if you want to call something which is outside Azure. The workaround is that you can use an API management server. You deploy an API management server in Azure and you link your external API to the API management server. So this procedure will still be calling an Azure address, the Azure of the API management server. The API management works as a proxy to an external API. This is an interesting trick, it's good to know, but it's not related to what we'll talk today. Today we'll be using Azure SQL to OpenAI, everything inside Azure. Okay, this is the syntax of the SP invoke external REST endpoint. So we have a URL, the payload. So if we make a post call, if we make a method post, a call post method, we send a payload. We send, for example, a JSON with the content about what needs to be done by the API. Headers, this includes the credential header, timeout, credential. Credential which will be used to authenticate. The credential is sent on the header, but not explicitly on the header parameter. There is a tweak to send the credential. I will show that. So here is what we need to do in relation to the credential. We need to get the API key. A service like OpenAI, this service offers an API key. We need to retrieve the API key from the service. Let me show this. Let me show this on the service. I get the resource and I can see here the keys and endpoints of the service. So I have the API keys here and the endpoints to call the service. The API keys and the endpoint to call the service. So we need to retrieve one of these keys and we need to use one of these keys to create our credential. The credential needs to have the name of the URL address that we are calling. The identity is a special identity, HTTP endpoint headers. This identity identifies that what we put as secret for this credential needs to be included in the header of an HTTP call, an HTTP call made by this procedure that we just saw. And the credential is a sensitive information. This needs to be securely stored. This needs to be encrypted. Uh, for the database to manage the encryption, the database needs to have a master key. We need to create a master key for the database, and only after creating the master key for the database, we create the credential itself. So, Azure OpenAI, the parameters that we need to send to OpenAI and how to use the Azure OpenAI. What to do with OpenAI in Azure SQL? Okay, I can call OpenAI from Azure SQL. What I'll do with it? Well, the possibilities are huge. I may create custom solutions according to the data. Every database, every application, every scenario may have a custom solution and is capable to create a custom solution. I will illustrate one of these custom solutions. We can just go to a generic solution and allow to use natural language queries. Yes, we can use OpenAI to execute queries from a natural language question. Just the user will type a question and will give the answer from our relational database. That's possible. Yes, it's possible. And a new feature that Azure SQL got very recently is vectors, support to vectors, vector search, and vector storage as a field type. This can be combined with the use of OpenAI and can create a very powerful solution. But this is the beyond this session. We would need another different session to talk only about the vector support in Azure SQL. So this is beyond our session, but is a possibility about what to do with OpenAI in Azure SQL. Then the parameter that we need to send to OpenAI, we need to send the prompts in a JSON format. You may notice here, I have a collection, an array of messages. Each message has a role, can be a system message or a user message. I mean, can be a system prompt or a prompt sent by the user. The system prompt usually we leave it ready, prepare to explain how we want the model to behave. The user prompt is something that we may leave open many of the times. And we need to build this JSON element to send to the OpenAI API. And here we have many parameters about how the model will work. We can fine tune these parameters if we would like to improve the model result, but I will not go deeper on these parameters. JSON functions. So we need to build a JSON. Some JSON functions will be very useful to build that JSON. JSON object. Using JSON object function, we can create a JSON object, how the name says. We can create a JSON object with many properties. And JSON array. Using the JSON array function, we can create a JSON array with multiple objects in the array. So in this way, we can build the JSON to send to OpenAI using these functions. See, JSON object, I'm creating an object to send as the payload to the call API call. Then I have JSON objects building the message. Each one of the messages needs to be built using JSON objects. Inside the message, I can concatenate actual information. I can be retrieving data from my tables and sending to OpenAI. If I'm not going to retrieve data from my tables and send to OpenAI, why am I doing this? Why am I doing this in SQL? So the idea is that I retrieve some data to send to OpenAI and get an answer related to that data. So I can concatenate this data inside the message, the JSON message that you send. See another message, the system message and the user message. The user message is received as a parameter in this case. And I build an array of message. The message element in the JSON object is made by a JSON array function. The other ones are just properties and values organized by the JSON object function. Let's see this working. First, the create credential, just to review the code. We have the same code here. I'm not showing the APIs and passwords that I'm using, the API keys and password that I'm using, but it's absolutely the same code. I already created this object in the database before the session. The database I'm using is this one, Adventure Works Production, which is in fact an implementation of the Adventure Works Liro. When you provision an Azure SQL database, you have the option to provision a sample database. The sample database that you can provision is an Adventure Works Liro with the same tables that I'll be using during the demonstration today. These same tables related to sales Liro, which will be part of the demonstration today. Okay, this is about the credential and about the JSON, creating the JSON parameter. So we have here the code similar to what I illustrated before, and I'm building the JSON parameter to provide to OpenAI. And I'm using a system prompt. What's the idea here? I'm putting a system message, I'm defining a system message for the OpenAI to work as a marketing specialist and generating marketing resources. And I want to send some products and get some marketing resources for these products from the OpenAI resource. So this is what this JSON payload will achieve. This is an example, it's not the final code, but we can already see how it builds the JSON payload, returns a JSON for us. The variable becomes a JSON, and I can take a look on this JSON. I like to use the site JSON Hero to visualize and evaluate JSONs. So we can take a look on this JSON. This is the JSON I illustrated before with the message that we will be sending to OpenAI. Okay, so we saw how to build the prompt. Now, building data for the call. I just mentioned I would like to build marketing resources. My custom solution is to build marketing resources based on some products. In this case, I need to list products from my tables, but to list the products from my tables, I need to add these products to the system prompt, which is a JSON. So I need the result of this list to be in JSON format. My query needs to be in JSON format. In this way, I will use more functions to retrieve the data. I will use JSON object again, and I will use JSON array AGG. JSON array AGG is an aggregation function which was recently included in Azure SQL and allow us to aggregate records in a single JSON array. So if I can transform each record in a JSON object, the JSON array aggregation will join this JSON object in a single JSON array. The JSON array AGG produces a cleaner result than the previous solution. Previously, before this function was released, we had the for JSON auto that we could include in the queries. The result of this function is cleaner than the for JSON auto. I wrote a blog post about this. I have a blog post about this. If anyone wants, you can reach to me, and I can provide a link to the blog post with many details about difference between this function and previously existing functions. So, here are the queries that I'll be executing. The model in this table is in this database is broken down in many tables. So to actually retrieve the data, I'm retrieving from products, join to category, join to product model, join to product model, product description, and join to product description. Then I'm choosing to retrieve some categories of products. I cannot retrieve all the products and ask to OpenAI to work on it. Why? Because the prompt has a size limit. OpenAI has a size limit in relation to the prompt. So if I retrieve too many products and try to put inside the message, I will go over the size limit, and this would be a problem. This first one is this query itself. Then the second one is the query transformed in JSON. How am I transforming it in JSON? First, for each record, I create a JSON object. For each record, I create a JSON object transforming the fields I'm retrieving in properties of the JSON object. I will still be retrieving many records. Then I use JSON array AGG to aggregate the many JSON objects into a single JSON array. In this way, I can retrieve this result and concatenate this result with the prompt later. So we can retrieve the data result and concatenate with the payload that we'll send to the API. So let's see this example. It's basically the same that I illustrated in the PowerPoint. I have the query showing that I'm retrieving the the products. So these are the products that I'm retrieving. And then I have these in JSON format. I'm retrieving these products in JSON format. We can take a look on this JSON using JSON Hero again. So I can take a look on this using JSON Hero. Something was cut. The JSON may be too long. It was cut, but when used in variables, it will not be cut. Okay, let's proceed. So the next steps, we know how to build the prompt, we know how to retrieve data. So how to build the call to the OpenAI. So we need to use the invoke external REST endpoint here. Invoke external REST endpoint. So we build the address. The address has a specific format. This format is a specific format for the OpenAI address. The only variable inside this address is the name of the deployment. GeoLake is the name of the deployment that I have inside Azure. Is the variable that I have in this address. Then I have the credential. I'm pointing to the name of the credential, which I'll be using, which is the URL I'm accessing. Then I send the payload. The payload needs to be built at this point. And the response is an output field, an output parameter. I'll get this response back. And this response will come in a JSON format. This JSON of the response has a choices element, result choices element, and inside the choices element, it has a message element, which is the actual result. If this message element will be in JSON, will be in plain text, this depends on the question that I'm making, on what I'm requesting to the OpenAI. And depending on the result, the format of this query to extract the result can slightly change depending on how I'm retrieving the result. So the output and the query to show the result. And the final touch is that we can transform this call into a stop procedure. We can transform this entire call into a stop procedure. And finally, we can make the question itself. Uh, for example, let's say that I already transformed this call in a stop procedure called get answer. What I'll do here, first I'll retrieve a set of products as a JSON array. I'm retrieving a set of products as a JSON array. Then I define the query that I will ask. Um, Build sales plan with discounts for buying some products together. The message here is cut, but basically is a query to plan some sales, combining the products that I'm sending to OpenAI. Then I call the procedure passing the parameters. In this way, we encapsulate the complexity of the call of the OpenAI inside the stop procedure. This procedure get answer. The complexity of the call is encapsulated inside the procedure, and we get the return. We get the return also in the reply, which is the output. Let's see an example. In this example, I'm executing the business scenario, the specific scenario where I'm building sales, and creating sales for combination of products. I'm asking OpenAI to create sales for combination of products. Let's see how the store procedure is built. The parameter the store procedure receives get the procedure get answer. It receives the model name, it receives the search text is the user question, it receives the products, is the JSON of the products, the list of products that you send to OpenAI. Then we build the payload inside the procedure. We are building the payload using the JSON functions to concatenate the objects and check how I'm adding the products here and the search here, the user question at this point. And finally, we make the API call. The procedure receives the deployment name as a parameter. So I'm concatenating to the URL the name of the deployment on Azure. This is passed to the procedure as a parameter. And the rest is similar to what we saw before. I invoke the procedure. The URL was built as a variable. I specify the header, content type, method post, the credential I'll be using, the payload which I built before, and get the response. And then to actually retrieve the response, we use the select over the response variable, the output variable, deciphering the JSON that we get in the message, in the answer from the OpenAI. Okay, then let's call this procedure in a similar way as I illustrated in the PowerPoint. So I'm building the array of products, building the array of products to send to the procedure, build the question that I'm building, build a sales plans with discounts for buying some products together. Organize the sales in a way the set of products is useful and makes sense to the buyer. And create an announcement explaining the sales and how useful it is for the buyer. Okay, and then I make the call. Get answer, GeoLake, a search text, the products, and the reply. Uh, Inside the get answer procedure, I'm making a select showing the answer. So I can already execute this. Let me check. This result means that my query inside the procedure, my query inside the procedure is not precise. I have here the actual JSON that the OpenAI returned. Let's evaluate this JSON inside the JSON Hero site, and see what the API actually returned. Result, choices, message. Okay. It's bringing many information here, and it's not actually a JSON. That's why the select failed, but it's bringing me the answer. But the answer is not in the format that I expected. This kind of thing we need to tweak a bit by working on the system message to be fully in JSON format. Each resource should be a JSON object with the properties defining the object and included in an array of resources built by you. Any reasoning needs to become a JSON property in the object. Let's see if it gets better. Okay. So I changed the system prompt that I'm sending in the procedure. Now I will execute again. And there is the result. There is the result. I forced it to send me the result in JSON. So I can get this JSON and read this JSON in JSON Hero. Let's analyze the sales that is given to me. The two different plans, and it gave a name to the plans. Cycling Essential Set, and the second one, Professional Cycling Kit. It put a description on the plan. Get our essentials for cycling gear in one discounted package, and the products which are being recommended. The two products from the set of products which I sent that are recommended to be built in a set. And another one, professional cycling kit, upgrade your cycling experience. So I have a marketing call and the products that should be included. So what we achieved from T-SQL, from Azure SQL using only T-SQL, I made a call to OpenAI to build something, to create something from the data that I have in my database. That's very good. And that's one of the examples that I mentioned as possible. I mentioned I can I can create uh, specific results according to the business model. This business model in Adventure Works Little is sales. So I created a marketing example. But I can create as well something more generic. Can create something more generic like a natural language processing. I can ask OpenAI to answer my questions about the database. What are the secrets for creating a natural language processing using OpenAI inside Azure SQL? What are the secrets that we have in relation to this? Well, one of the main secrets is how we build the system prompt. how we organize the system prompt. This system prompt is not actually very small, it's big, and we need to describe the system prompt, all details of our tables. I'm describing the tables we have, the fields we have in these tables, and the relationships between the tables. Basically, I'm describing to OpenAI the model. Why am I describing to OpenAI the model? Because it's not OpenAI who actually get the data for me. What OpenAI can do for me is to build a SQL statement which I can execute. So that prompt is asking OpenAI to build a SQL statement. Then I get the SQL statement as a result and execute it. Let's take a look on the procedure I built to make this happen. NLP query. So I built the payload with this huge system prompt. This procedure receives um, a question as a parameter. So the actual question of the user. So I have the huge system prompt and the user question in the payload. Then I make the call to OpenAI. I make the call to OpenAI, passing these parameters. Then I retrieve the SQL generated by OpenAI from inside the message because the format that I ask it to be generated, the query is slightly different. We always need to analyze the JSON of the response to define the query that will actually retrieve the result we want. But the result I want is the data, so I need to get the SQL generated by OpenAI and actually execute. So I ask to execute the SQL. That's it. So uh, in this example, I'm making calls to the procedure and making queries in natural language. Could you show the total of sales by state? Here's the answer. And this previous query here is like a debugging query. I'm showing the actual JSON response, JSON reply, but I can just remove this from the procedure later. So I have here the total of sales by state. Another example, could you show the total of sales by state and category? Let me try again. I tried this query before the session and it worked. The model was in a bad mood and created something wrong and then finally gave me the answer. Maybe we need to tweak the parameters like the creativity of the model, tweak some parameters for the answer to be more consistent. But this is about the parameters that I mentioned way before inside the JSON that we sent to OpenAI. Another query, could you show the customer with the highest total of orders? It's showing me the customer with the highest total of orders. Could you show me the product with the highest amount of orders? So it's showing me the product with the highest amount of orders. So in this way, I built a step procedure which allows me to make natural language queries over my database. Of course, the point is not to make these on an SSMS. The point is that using procedure like this, you can add natural language queries capability to your application which is accessing the database. Your application can receive a question from from your customer, your user, and process the questions and the answer back to the user. So we included the natural language processing capability into the solution. Okay, so in this way, we're talking about how to make the queries. OpenAI generates the SQL query. We execute the generated SQL query. It's not OpenAI that gets the data. OpenAI generates the SQL query and we execute the generated SQL query. We need to explain the model to OpenAI using the prompt. We use the prompt to explain the model and get the generated queries. We already saw the example of the natural language queries being executed. This is my GitHub. The files are not uploaded there yet, but I will upload today, later today. I will upload the files to the GitHub so you can get the files, the sample files for this presentation from GitHub. So, that's it. Thank you very much for attending this session, and I would like to know if you have any questions.
Wow, thank you, Dennis. This was an amazing presentation, very deep technical level. Uh, I wonder if you don't mind, I have a question. How much time did this demo took to make it real? You know, how much time did you spend preparing the demo? You may have done it in the past. I don't mind.
It is difficult. It's difficult to say because I delivered another session
Yeah,
which was similar but
similar.
not exactly the same.
Okay.
So if you ask how much time I spent preparing these exactly demos for this session, it took one day
One day,
preparing the
one day.
demo,
Okay,
one day
okay. That
preparing the
makes
demo.
sense. That makes
But I used the per pieces of code that I had prepared from the previous one, which took 2 days or something like that,
sense.
but was about the new features that Azure SQL has, about
Ah, okay.
vector search. This is more
Yeah,
complex. And this adds more to this session,
yeah.
but to talk about vector search, it needs to be a different session.
Wow. Understood. Understood. Great. Well, I want to thank you so much for being here with us. It was an honor to have you here, and we are so grateful to be able to see you. Let me see if we have another question here. You got so much clarity to this. I always thought OpenAI could see the database structure. Is it possible to include a file within the system part of the prompt, a file that contains the schema for the DB? Another question from James. Okay, do you want me to repeat it?
Um, there are many levels of answers for this. Let me try to clarify what I mean.
Okay,
Um, um, the prompt never contains a file. Never. The prompt never contains a file. The prompt is always a JSON format. It always contains text. It always contains text, never a file. Uh, but but there are some features inside the OpenAI resource which are capable to add to the prompt. For example, let's say that we want OpenAI to search PDF files. We could link the feature of index search to OpenAI, and this would be build the prompt for us. We will not see. It will appear like the files are attached to OpenAI, when in fact a lot is happening in the background to build the prompt for us. So On the core of the answer, the prompt can never contain a file, let's say on the core of the answer. But the OpenAI feature in Azure has some resources to link files to allow OpenAI to answer questions about these files. But I would not use this for the database schema. I would not use this for the database schema. The database schema is still need to be explained. I would still explain it in a prompt. If for some reason you had the idea, oh, maybe if I put the schema in a file, I save more space in the prompt to be able to send a bigger prompt. No, because if you put in a file, in the background, OpenAI will get the file and join the prompt. You will not save space in the prompt. You will not save on the token numbers that you are consuming in the prompt. So it's possible there are some complexities, but I will not do for this purpose, for this scheme of the DB. Okay, James?
I guess I guess James got the answer he uh, was looking for. Thank you is the response. So yes, thank you, Dennis. I don't know if anyone else has any other questions. We have your contact as well, Dennis. So definitely we're going to come back to you in another event of ours. And of course, now we are connected in social networks. I will reach out to you. Um, Again, thank you so much for being with us. It was a pleasure meeting you, Dennis. Have a great
Thank you
one.
for thank you for accepting the session, for inviting me. And anytime you would like to invite me again, another session, I'm available. Just let's
Definitely.
schedule.
Proud that I found you. Definitely. I would like to discuss so much with you for another project I have in mind, but it's not the time here. We will do it offline. And have a great one, my friend. Bye bye.
Okay. Thank you. Have a nice day. Bye.
Bye bye, my friend. So yeah, that was Dennis. Amazing session with a real time demo. You know how difficult it is to deliver a real time demo, right? Everyone who has ever been in the speaker's position knows the challenges when you have to deliver something live. Great. We are moving on. Day four, Azure AI Connect 2025. Thank you everyone for being here. And if you're not live and watching this recording, thank you so much for supporting our communities. Remember, this is an effort from both communities, Azure Innovators Hub and the Azure Developer Community Tamil Nadu. Um, I have to say I'm so grateful for stepping in and helping with moderating, creating the designs, the graphics, having sessions with me to plan this immense amount of sessions and speakers and make it as much as comfortable as possible for everyone, including you, the attendees. Uh, at the end of the day, this is for you, and we hope so far you are enjoying it. I'm going to add now a video while we wait for our next speaker. We may have 10 to 15 minutes until the next speaker comes on board. So allow me to add our break video. Let's have a coffee, let's have a water or a juice, and we'll be right back. Thank you, everyone. Right, we are back from our small break. We have our next speaker with us. Our next speaker is, let me pronounce correct the name, is Giulio Sciarappa. I think I'm pronouncing it correctly. Identify and mitigate production issues by adopting AI ops in Azure Monitor. What an interesting theme. You know, AI ops, another new term introduced with the surge of AI into our daily operations. AI ops is going to be a term, a methodology probably that we're going to see more and more, especially when we are dealing with our artificial intelligence infra applications, Giulio, I think he has the credentials to speak about it. So let me welcome Giulio on the stage. Welcome, my friend.
Hi everyone, nice to meet you, and glad to be here to speak about AIOps and how we implemented it in our company. And yeah, I'll be glad to tell you more stories about that.
Amazing. So we're going to have an actual case study here with Giulio, right? Is that correct?
No, not an actual case study. I will show off some of the things we applied in terms of
Okay.
AIOps in the different companies we are working for. So we are a consultancy firm as Lobra Futura,
Okay.
and basically, yeah, we will show you off some of the use that AI ops at the moment is enabling throughout the various portal resources. Let me say this way.
Amazing. Thank you so much,
Great.
my friend. The stage is yours. So
Okay, thank you.
you're driving.
Okay, so I'm going to present. One second. Sorry, Konstantinos, it's taking more time than expected to load the presentation. I hope it's
No
not
problem.
an
No
issue.
problem. I will wait for you. No problem.
Thank you. It's taking ages. Okay, I think everybody can see the presentation. Can you confirm it? Uh, Here I am again. Sorry. Okay. Okay, now everybody can see. So thank you and sorry for the little bit of delay. Basically, this is a great opportunity for everybody to speak about and hear about AI, and I'm glad to be part of it. So please follow the next sessions also, and not only mine, but I know that one of the main guests. No, I'm joking. But here I am for the identify and mitigate production issues by adopting AOps in Azure Monitor. I hope the majority of you has at least heard about Azure Monitor and what it is. Basically, Azure Monitor is one of the resources, one of the solution that Azure has put in place to continuously monitor what happens behind your programs, behind your production issues and everything else. So basically, everybody of us, as in the past years, in the past months, in the past days, had issues in production or in very important environment. But the difficulties we are finding, everybody of us is finding, are basically there are too many logs. There are difficulties in automating processes between the discovery of an issue and the resolution of an issue, and even more to find the issue itself. Sometimes it's like finding a needle in a haystack, as the image suggests. Then, I hope the majority of you have heard about DevOps. DevOps is a methodology as well as GitOps and as well as AIOps. And DevOps is one of the best methodologies that our world, the IT world, has met in the last year, due to the fact that the DevOps methodologies allow us to close the gap between the programmers and the operational people, the people that in the end brings your stuff in production. Therefore, DevOps, let me say, laid the foundation of what has come. Then a few years ago, it went up the possibility to have GitOps, so to move everything that is under Git in terms of infrastructure and also other part of the IT world, and automate the release of those stuff in production, leaving almost nothing to pure manuality, but majority of the things were made by automation. And today I'm presenting you what is AIOps. So the possibility that are given to improve what is the IT operation after the release in production. So today we are seeing what Azure Monitor, which is, as I said, one of the best tools that Azure gives us, gave us in terms of possibility. We will look through log monitoring, application performance monitoring, metric alerts, and virtual machine skill set. Basically, who used the application insights and Azure Monitor had the opportunity to have multiple logs and multiple graphs and information about the program, about the resource, about the use of the resource and everything else. What nobody told us is that we can also have the insights about the log itself. So considering the log itself, the logs itself, in terms of ingestion, in terms of anomalies, in terms of everything else, as another value to be seen. We will look through it later on in the demo, and we will check how it can help us to identify issues that sometimes are very well hidden. Another option that is giving us is to build time series based on AI, which allows us to analyze and have a graphic details, a graphic visualization of where the issue is and how to find better the issue. It's really, really easy to unleash the power of machine learning in this case by the use of KQL. I don't know if anybody who is following this presentation has had the opportunity to try and to use KQL. KQL stands for Custom Query Language, and it's an SQL-like language, which basically gives us the opportunity to query the logs, query the insights, query everything regarding the logs and the monitoring in an SQL-like language in a very, very, very efficient way, and in terms of cost and in terms of time. That's an example of how do you make a time series. Later on, we will see in better in the demo. But basically, once you have a normal search, you can put it in a graph and highlight automatically eventual anomalies. Once you create a normal time series, you basically have just the graph of the events you had based on the time they has happened. Let me say this way. One second. Okay. Can you hear me? Yes, I hope so. Okay, great. What gives us the real power is then the opportunities to apply machine learning operation in KQL and on the time series. In this case, I'm showing you the series decompose anomalies, which basically goes through the entire process and highlights when some anomalies has happened and why they are considered anomalies. You have to consider that an anomaly is if you always have some logs with some errors, and on a specific date, on a specific time, you have a spike on those errors, that's an anomaly. That's an anomaly because it basically simplify the whole curve of errors and highlights what is not normal. And the series decompose anomalies serves exact to that. Giving you have to give him the series, you have to give the threshold and the method, and then the method that you're using. So if it's linear or non-linear, and then it gives back exactly what you see here. Later on, we will see it better, but that's exactly what you see. So basically, you are able to see that you had a lot of errors or anomalies throughout the day, some spikes. Then that's just one of the opportunities given by um, the, the machine learning included in the custom query language. Those are a few others, such as series outliers, series fit line, periods detect, and fit linear. Outliers, as I said before, it's giving you the opportunities to find the outliers. So not all the anomalies, but what between the anomalies stands out, which is very different. The fit line creates a linear regression on the time series, so we can prevent what is going to happen. The periods detect, it's really helpful to find out the seasonality, the periodic patterns that a specific time series is giving us, and then the fill linear, which is helping us to do the linear interpolation for the data that are supposed to be there, but they are not there. Last but not least, and then I promise you we are going to have a small demo, there is the opportunity to have Copilot, so to use the large language model of OpenAI of GPT included in Azure. Azure included in itself the opportunity for us to have a look on what Azure itself is having. So it's exposing the resources, it's exposing the information to this specific Copilot dedicated on Azure, in which you can use his help to create the queries, to have some information about your subscription and to understand better your own subscription, your own tenant. We have any way to taking care that we can just have information about 10 resources that the top 10 resources, let me say this way. So if we are asking Copilot, hey, how many resources we have deployed in that subscription, or can you list me the resources in that subscription, we could expect to have nothing more than the top 10 resources. As well, since it's a preview, we need to understand that at the moment, Copilot in Azure, it's a preview and it has no cost connected to it. we can make maximum 15 requests, so 15 messages between me and the chat, and the maximum of 10 chat every day, every 24 hours, let me say this way. Also, sometimes the responses that are given on the maximum of 5 items, and sometimes it's not working with the resource name, but it's required the resource ID. Even more, so those are few tough limits, I understand. At the moment, it's available only in English, which I suppose is not a problem for me and neither for the people that are hearing me at the moment, but it has to be taken in consideration. Finally, it's demo time. I'm going to show you something. Okay. Okay, I'm not sure. Okay. Everybody now should be able to see what I'm showing. So that's an example. That's the most important things of what I said before regarding the insights on the log. So we're not speaking anymore about the log itself in terms of what is happening, but I'm speaking about the possibility to have insights on what happened in the ingestion of the log. So what we can see here, it's nothing of the data, no data of what we are seeing actually, no data regarding our program, but on the logs itself. So what we are seeing is that in the last 24 hours, we had a total volume of around 200 megabytes of app traces. We had around 68 megabytes of performance counters, 30 megabytes of exception, and then fewer of app metrics, and even fewer from app request. So we can see easily what we are logging in terms of that. And we also can see the same information split by the time we are using it. So we do understand that between 5 and 6 a.m., 5 and 7 a.m. in the morning, we have huge spikes of information. But in the same time, we can see the same information regarding the exception. So as well as a bigger amount of logs, we have also a bigger amount of exception. So there is something inside, as you can see, we can detect by this simple visualization that something is telling us that at this hour we have more information, like 3 times more, but we also have 10, 20, 50 times more of exception, which is an issue, and we can take care of that as well. And that's the most important things. We can see the anomalies, so we can see what happened in an historical way. I'm going just to show you on 28 days to give you a better idea of that. On 28 days, we can see that today we ingested 23 megabytes. Yesterday we ingested 40 megabytes, but then a few days ago we ingested 593 megabytes. So what happened on those days? On these days, we can then look at the logs of these days and understand if something happened. The majority of the time, we do not see an issue unless the business tell us so, due to the fact that it's simply logging a lot of information. As you can see here, there is a huge spike of errors, and we cannot understand this information because those are simply logs. We haven't put a single alert on it, and then we have issues on that. Then we have the usage that allows us to understand what happened in a specific moment, in a specific time, and from where the information has been taken. Then the health, because sometimes there are issues in the ingestion, and if we are missing logs, sometimes we are wondering, okay, my application is not working as expected, or how can we do that, or how can we solve this issue, and then we get stuck. But sometimes it's not due to us, it's due to Azure, it's due to um, the cloud system itself that is not working as expected. Then for the agents, you will not see anything here because it's for the agents that are ingesting the information from the Windows clients. So whenever you have an agent on a Windows client, you can see the information here from the Windows client itself and understand better what happened on those agents, as well as query audit. Whenever you enable an application inside installation and an application inside resources, you can also enable a query audit. So you basically log all the information of the manipulation of the logs. In terms of healthcare, in terms of banking, those sectors require that every time a person is asking some information to the logs, this information should be logged. So the details of the query on the log should be logged itself. And this is helpful on this case. Data collection rules, if you have set up specific data collection rules, it's given here a better understanding, as well as change log. So if anybody has done anything to the log in terms of deleting, adding, changing, allowing more permission and everything else, you can see it here. I'm going fast forward to the time series. Basically, the time series, it's a very easy. I'm giving you a bigger screen. It's a normal query, as always, with the availability result, request, exception, page view, etc., and etc., and etc. What we do is to simply asking it to create a make series. So we just add the make series of the total events count, taking care of the errors in this case. So the total events are all the events we're having. The error events are the ones in which the success is different from true, from a specific timestamp. And then we're asking the step of 1 minute, 10 minutes, 1 hour, etc., and etc. And we ask to render a time chart. Just running it takes some time, obviously, but it gives us back, as you can see, an easy way to recognize what happened in terms of error events, which are lower, as you can see, and in terms of total events. So what happened, when it happened, as you can see, there are few errors, few opportunities that happened during the days, and the error events are localized here. So it means that I have to look the logs in the specific time frame. That's the simple use of make series. It's really simple. You just ask it to make a series, you give it a name, you give it a count or a specific function on a specific value. And in this case, you put the time related field here, specifying from when to when and which step it has to consider. I'm adding a specific point to show you more about that, to give you more information about the ML functions. So I'm removing the rendering and I'm adding this. With that, I'm just extending. So in the KQL language, the extension is allowing us to show, let me say this way, um, to show more columns that are not natural, but are obtained through different functions. In this case, I'm receiving the series anomalies by looking at the total events and giving the total events, so those number of events, the analysis made by the machine learning. Doing that, I'm extending the anomalies, the anomaly score, and the expected usage. Then I'm just showing the column as a different column in the result. So we run it. It will take some time too. But that's the example. So on the 27th of February, we have in this specific time frame, one anomalies, which anomaly score is way higher than expected. So we basically know that we should look the logs in this specific time frame. And considering those time frames, we haven't done anything. Basically, we asked, hey, can you show me the log? And then the logs, can you put them on a nice chart based on the time they arrived, so I can understand when we received more information and when we received less information? And then I'm asking it to analyze it using the machine learning, some machine learning basic function included in custom query language. And doing that without any particular knowledge on that, I can easily understand when to look the logs for any specific errors. And this is exactly what we're looking for. Then, last but not least, we can use Copilot to ask him further information. In this case, if we don't know how to make a query language, sometimes we can ask, can you help me to create the KQL query to understand the average time for the response? It will take time, it will think on it. I'm not sure it will work all the time because it's always changing. As I said, you can see here it's in preview. Again, this is not working as expected. And it's not the first time that it happens. Asking it again probably will give me different answer. Preview means that you should rely on it to understand what happens, but and help you throughout the work. But preview doesn't mean that it's always working. In this time, it worked. We have request. We have summarize average duration by bin, by a little bin in which we can put timestamp +1, -1 in this case, and then we just run the query like that, and it makes the query run here. We don't have the results in the last 24 hours, but it did it, including it here. So as a perfect copilot, it's helping me throughout my work. Another question we can ask him is to telling us about our subscription, about our cost. In this case, I'm asking it, can you give me the distribution of resources across my subscription? And it's checking, it's giving me the answers on my subscription specifically. It will take time as always, but it's doing the job for me, telling me what I need to understand. In this case, is making the request so I can run the request itself and I can change it, but then it's giving me back the results. Giving me, as we said before, with those specific and extreme limits, the top 5 resources. Going back to the presentation. Okay, here we are. I'm going fast forward, so if anybody has some question, can write in the chat or ask me. Eventually, Konstantinos or Romana, if you are also following the YouTube, you can just give me the information from that. Then let's move forward for the application map, intelligent mapping. That's something that it's since, let me say, the beginning, but it has greatly improved in application insights. It's an amazing opportunity to visualize your infrastructure, visualize your programs, visualize your calls through the programs, through the different processes in your company, in your programs, in your microservices, in your web app, etc., etc., to follow them and to understand where the bottleneck is, where the most errors are, and etc., and etc., and etc. This is an amazing tool given and served to allow us to understand and proper assess what is happening, basically showing us the time of response and everything else. I'll show it later on in the demo. Then there is the smart detection. Basically, the majority of us, when we have to do some monitoring for a specific client or for ourselves, we simply look at the logs whenever some errors happen, and we understand a perfect alert to expose. Then, with smart detection, this job is made automatically by application insights itself, giving us back some information about what's strange is happening in the logs. How it's working? Basically, it looks through the entire log base, and it creates some patterns. It creates some history. And then whenever something strange happens, whenever something not regular happens, it's allowing us to understand and to check if something wrong has happened. It doesn't mean that it's an error, but it's showing us that on a specific day, on a specific time, we had a huge increase of error in that specific point. Going fast forward, we have the opportunity to use the dynamic threshold alerting. What is the dynamic threshold alerting? We are used to put alerts such as whenever the CPU is 80%, give me the alert. Whenever the CPU is 90%, give me another alert, etc. and etc. But what happens sometimes? Sometimes it's happening that there is not such an 80% use case, but there is a rapid increase in terms of 50, 60, 70, 80, 90 in terms of 20 minutes. And what happens after 90%, 100%? And what happens at 100%? Our resource is stuck the majority of the time. So what we can use to avoid this, or to give you another example, sometimes we have the resource that is always working at 80% or at 60, 70%. So if we have a peak on a specific day, on a specific time in the day, it's okay. Like I say before, at 6 o'clock in the morning, we have some batches that are running. So we do expect a general increase in terms of consumption, in terms of resource use, etc. and etc. But what happens if at 4 in the afternoon, I have a huge and extremely increase from 10% to 90%? That's something we need to take care of. And we need to be very fast on that. With dynamic threshold, we can say, hey, please look at the historical data of this alert and adapt to it. So instead of looking at 90%, is looking at the historical data. And if the historical data of the last 10 days or 10, 15 days are normal, if there is a simple specific spike, it looks to it and it gives us back the alert. And that's amazing because you can put a single specific alert for multiple resources, saving money because you have less alert, which costs less money, but it's working throughout the different resources shared by the same topology of resource. Last but not least, we have the predictive autoscale, which is another amazing resource given us by Azure. So basically, whenever you're using the virtual machine, you have the opportunity to use the virtual machine scale set. The virtual machine scale set, it's an extremely useful resource that gives us the possibility to create and instantiate a virtual machine in terms of minutes, putting it the setup required for a specific virtual machine. So if we have a web server, to give you an example, and in this web server you have the the site, and we have a spike of visitors in the last 10, 20 days, or 10, 20 minutes, even more. What we usually do is to provision another virtual machine, install the same programs, and share with the use of a load balancer the people that are visiting the site between the two different virtual machines or three different, etc. and etc. and etc. The scale set serves exactly to that. So whenever a specific value, which can be a CPU use, RAM use, or HDD use, etc., and etc., or input output or network use, we can just scale another virtual machine and load balance it. That's perfect, but again, as I said before, not all the time we can prevent the crash from occur. Because if we put 50%, every day that we have more than 10 visitors, 50 visitors, 100 visitors, 1,000 visitors, we then instantiate another virtual machine. But sometimes, even if we reach 80%, 90% of the use, it's not too much. It's something that we can take care of easily. But with the predictive autoscale, we say, okay, not all, take care of the 50%, 60%, 70% we decided before. But instead of starting the virtual machine as soon as we reach the specific level, make a predictive analysis. So don't be reactive, don't react on the reaching of a specific percentage, but be predictive. Start to look through the last 15 days data at this specific time of this specific day, in terms of the days of the week, what happens at this specific time, and if the normal user of that specific day is 100, and today we have growing up from 50 to 100 to 150, we do expect to reach the 70% in 3 hours. Great. In 1 hour and a half, I'm starting the virtual machine, so I will not reach that specific point. It will cost a little bit more because it's predictive instead of reactive, but it will save us from being stuck. And that's the most amazing part of the predictive autoscale. Let's have another demo on that. It will take some time, but I'll show you. Okay. Okay, so basically what we had here, it's the application insights. What we saw before, it's the application map. The application map, as soon as it loads, obviously. Let me refresh the screen. As you saw in the slide, it's a demo time. If everything goes right, it's not a real demo. I'm sorry, but that's the way of Microsoft. If it's a demo, it's not expected to work on the first time. Jokes apart. Okay, so here it's the visualization in terms of what happened in our infrastructure. Those are the services, but let me show you this way. In the last 30 days, we then have a visualization of the connection between the different nodes of our application through the web app and through the storage. What happens when they write, when they read, etc., and etc. And we can go in deep on that, having the slowing request by name, having the alerts enabled on it with a short click on it. And obviously it changed. Let me do that again. And we are able also to highlight the different timings of the calls and see that there are some calls that just take 6.8 milliseconds, while there are other calls that takes 44, others that take 50, others that takes 20, etc., and etc., and etc. This is amazing because it's also giving us the opportunity to see how many calls, the average time, the number of alert, etc., and etc. If we go on that, we can see the slower request as well as the different opportunities to go and see the specific performances, failure of this specific function in this case, as well as to go to the overview and check the function itself. The smart detection, as I shown you before, it's not something that gives you alert unprompted, but it's something that you need to go and check. And it's showing us that in those days, at that specific time, we had something that was not expected. So we had 90 DB2 file API exception on this specific time frame, so between those hours, while in the last week it was 0. So we should take a look on that. That's another amazing way to work on it. Then I'm going to show you the alerts. as I shown you before. We can create a new rule based on virtual machine if I can have it. If I took the right tenant, because it happens. Okay, let me change it this way. In this case, I have a specific virtual machine, and in the condition, I'm going to percentage of CPU in this specific case, but instead of putting static threshold, I'm putting dynamic threshold. And when I'm putting a dynamic threshold, I then have to change and have all the opportunities to modify the value. But the most important thing is this one that we can easily see as soon as it loads, the actual amount, as well as you can see here, if I can highlight it, the value compared to the specific moment. So in this case, we have a spike, which is not expected, and we should have received an alert in this specific case, even if it was just 40%, but we would have seen that something wrong has happened in that specific time, in the specific time frame. Last but not least, I'm showing you the virtual machine skill set. Oh, sorry, wrong tenant. Okay. As you can see, the virtual machine skill set, whenever you go on availability and scale and scaling, you have the opportunity here, instead of scaling just reactive, you can have it disabled, enable, or just forecasted. Just forecasted will give us just the opportunity to see when it's going to scale, but it's not actually scaling. That's basically the possibility that we have, and it's really easy because as soon as we set up the scaling, the auto scale, we have the opportunity to put it as predictive forecasting or disabling it by at all. The interesting part of it is that the rules the predictive auto scale is abiding are the same rule of the normal auto scale. So if we say that the average percentage should be under than 50%, 60%, 100%, in this case was 80%, then it scales, but it's doing it predictively instead of reactively. Going back to the presentation. Okay, I have just a bonus slide. So what I've shown you today is the opportunity to use AOps included in the Azure Monitor suite, let me say this way. Obviously, that's just the start of the game, because that's just few function, few opportunities to use the AI to help yourself throughout the day and in solving the issue you can see every day. But as you can see here in the slide, there are countless opportunities to go from that point on, but it requires you to implement notebooks, to implement PySpark or Pandas data frame, to fully work on that and to put the logs in a specific blob storage and start some pipelines, some Databricks, some PySpark pipelines in order to process them accordingly. So obviously there are some limits, but that's a great way to start from. Any question or answer, I'm here to reply to all of them. I'm giving you just 2 QR code. One is for the documentation I've just discussed and I've just shown you, and the other one is my contact. If anybody of you wants to contact me and get in contact or get updated by me, just let me know, and I will be very happy to help you and to assist you further on.
Hey, Julio. Currently, we don't have any questions.
Okay, perfect.
The session was wonderful. We enjoyed a lot.
Thank you a lot.
Thank you so much for joining us.
Thank you.
That was Julio. Thank you, Julio, for being such a deep presenter on your session. Thank you very much. I'm going to add you again on the stage to say goodbye if you don't have a problem with that.
Sure,
So
my pleasure.
again, thank you so much for being with us.
It was a
I'm
pleasure
sorry
for
for
me.
that little pause. It's a big event. You may understand there are a lot of speakers, and we are very grateful you were one of them in our event. Hopefully, we will see you again in another
My
event
pleasure.
of
My
ours.
pleasure. It's a great event. I saw some of the other sessions from some of the colleagues that presented, and they were extremely helpful, extremely in deep.
Thank you.
So really hope to see the last sessions from today and tomorrow, and let's see in the next events if we have the opportunities to join. Thank you,
Thank you so much.
Konstantinos, for the
Thank you
opportunity.
so much, Julio. Have a great one. Bye bye.
You too. Bye.
So we are going to have a small break. I'm going to add our video as usual. Grab a coffee, grab a water. Azure AI Connect is continuing. Next speaker is, let me uh, pronounce it correctly. Our next speaker is Dr. Buma Pulan Marikaman with Revolutionizing Interaction with Azure AI Speech. I believe she will be here soon. Julio has done it in almost 45 minutes, so we can have a small break and we will be right back with you. Thank you, everyone. See you in a bit. Welcome back, everybody. Continuing with Azure AI Connect 2025. Our stream of amazing speakers is continuing, and now we have with us Fatih with threat or opportunity, enhancing software development efficiency with AI. Looks very interesting, and since AI is urging us to be more software oriented, and you want to deliver, you want to be excellent on what you're going to create, you have to get your hands dirty. At least this is my understanding and my lessons learned. I believe Fatih has more to say on that as a subject matter expert. Let me bring him on stage and welcome my friend. Thank you so much for being here with us. It's been
Hello,
an honor to
Konstantin.
have you.
Do you hear me, by the way?
I can hear you very well.
Really nice. Okay. Yeah, thank you for accepting me, by the way. I am happy to be here.
Great.
Yeah, yeah. Yeah, as you said, the AI in software development is really, popular issue nowadays.
It
So
is.
I hope I can tell where it goes in my view, in my point of view. So,
Yes. Yes. We can't wait for your session. So I will be on the backstage. Whatever you need, kindly write me on the private chat.
okay.
Would your session be around 50 minutes, something like that? 45? What do you think? 1 hour?
Yeah, it's actually 45 minutes or something, I
Great.
guess.
Great.
Yeah.
No problem. Take your time. We're not in
Okay.
a hurry at all. Take your time. You are on
Thank
the
you.
driver's seat. I'm going to be
Thank,
on the backstage.
thank
Thank
you
you.
very much. Well, hello everyone. Yeah, today I want to talk about a big question in our industry. Nowadays it's very popular. Is AI a threat or an opportunity for us as developers? So, actually, some people worry that AI will take our jobs. Others says it will make us more productive and creative. So, actually, let's see which one is true. Actually, what I share is will be in my opinion. So, yeah, as a note. So in this talk, I break down how AI is changing software development and how it helps us work faster, and whether we should be worried or excited about the future of the software development. Well, first, I'd like to introduce myself. My name is Fatih Kadirakın, and I've been a software developer for 17 years. Right now, I'm working as a DevRel manager at Teknosyon in Istanbul, Turkey. But beyond that, I love building things, contributing to open source projects, and sharing what I learn. And I've written books on JavaScript and prompt engineering. Actually, I also share open source work on my GitHub profile on github.com/f. Uh, just I wanted just to make a clearance that I'm not an AI expert. I'm just a developer, like many of you, I think, exploring how AI can make my actually life easier and our life easier. So that's what this talk is all about. As a last minute note, I'm awarded as a GitHub star today. So I also wanted to share this happy news with you. Well, before we jump into the impact of AI today, let's take a moment to look at how AI has evolved in software development. So actually, AI in coding is not new. It's been around in some for around us for years. Actually, from early rule-based systems to today's large language models (LLMs), AI has shaped our how we write code, how we debug code, how we optimize code. So I believe understanding this history helps us to see where AI is heading and what means that means for us as developers. So let's take quick journey. It won't be. I think it won't take too much time. Quick journey through AI's role in software development over the years. I don't know if you heard about Tab 9, but if you remember Tab 9, when I first saw it, when it first appeared, it was like a magic to me. It's beyond the auto completion. Before the Tab 9, auto completion was just like basic suggestions from the methods, parameters, etc. But it was not quite intelligent. Even though we call it IntelliSense in some Microsoft products, but it's not that much intelligent, But Tab 9 was actually so good. It can understand the context, it can complete the all line, and it can generate some parameter names that make sense. So it's like a magic to me. And it was the first tool that made me think, okay, well, there is something to do with AI in software development, and in that minute I said to me, okay, this feels like it's the future, and we came to the future actually more future to come, but well, Tab 9 was nice, but it wasn't too smart, and it was just a smart auto-completion, as I said. It could predict words and short code snippets, but it wasn't really thinking. It wasn't behaving like it's thinking. So it wasn't understanding the logic of the code. It was just like patterns. So at the end of the day, it was a huge productivity boost for sure, but it wasn't something that could write code by itself. That level of AI was still on the horizon. There was something to something more. So then the GitHub Copilot came out, and my mind were blown. It's a very, very huge improvement on what AI can do on software development, and I suddenly switched from GitHub to Tab 9 to GitHub. It was not autocomplete anymore. It was much more intelligent. It could generate entire functions, understand commands. It can write complex code. Actually, it started controversial discussions around the community about it's trained with the open source projects, etc. So. But actually, for the first time, I felt like AI was just not assisting us, but was actually coding with us. So it's just like a pair programming to us. That was the moment GitHub felt me, GitHub Copilot felt me like that. As you can see, an example of GitHub Copilot is it can simply write a function that counts the lines of the code in given directory, separated file extension. I just wrote a prompt as comment, so it autocomplete all the stuff. So let's think about the big question: will AI replace us? Yeah, actually, it's a quite big question the community discuss nowadays. So we all wondered at some point, AI is getting smarter and smarter day by day. Every day is a new there are new things to come, and automation is taking our more tasks, and tools like Copilot are writing real code. It's getting better and better every day. Should we panic or not? I think not. We shouldn't. But let's see how automation has affected other industries. Actually, automation is humankind's issue in quotes. We have seen automation transforms in many industries before. Let's take manufacturing, for example. The robotic arms have replaced many repetitive and dangerous tasks in factories. Actually, I don't believe it's completely replace the workers. Humans now oversee the processes, handle complex decision making, and maintain these machines. Yeah, some people moved from doing these tasks to another place, but it didn't take humans' job. So let's look at the retail and self-checkout machines. It changed the way we shop. They reduced the need for cashiers, and but they haven't eliminated the people in stores. Stores still need employees to assist customers, manage inventory, and handle situations like AI can't. So actually, the automation doesn't always replace jobs, but it changed the jobs. And the same question applies to software development. Will AI take over, or will it simply change the way we work? So in reality, this is not the first time we have automated our jobs as software developers. We like automations. As what developers do is automation, right? So over the years, we build tools to make our work easier. I don't believe not much people writing assembly code, right? No one is. Actually, I didn't, but we as developers build compilers and replaced manual machine code, and we invented and developed IDEs and automated syntax checking and debugging stuff, and we invited version control to make the collaboration processes seamless. So actually, we like automation, and we like we as developers, we are lazy people, so we are trying to automate everything as much as we can do. So every time actually we build something, people got some fear, I believe. So but the tools didn't replace developers. Actually, they freed us from boring repetitive work and let us focus on bigger and more complex problems. So in short, actually the AI is a tool. To me, it is not a replacement. We should behave it like a tool that helps us. So just like compilers, IDs, or even calculators, right? AI helped us work faster, automate repetitive tasks, and focus on what really matters. The coding part is actually not the main part. What we do, we build products, we try to make good things for the people. Yeah, right. We build products at last. So it's not here to take our jobs. It's here to make us better at them, I believe. So AI tools like GPT-based models, can boost productivity for sure, but they still have gaps. Actually, they don't always understand the context perfectly. They can generate incorrect or inefficient code, and they lack true reasoning. And that's why AI still needs human oversight, creativity, and problem solving. We still need the verification, yeah, right? If the AI wrote the code right or not. So it can help us, but it can't replace the way we think, that the way we make decisions or build truly innovative solutions. So building complex systems actually is not just about writing the code. The code is is a part of it. So it requires understanding user needs, ethics, and the real world impact of what we build. So these are the things AI that still struggles with. So actually AI can generate code, yes, but it doesn't truly understand the context, even though the latest IDEs try to understand the whole context, but it's actually augmenting it. it can't understand the emotions or the human behavior, so it doesn't think about why a feature matters or how it affects the people. Um, it's an AI. It doesn't know how we feel, how it will change our lives. So that's where we as developers come in. AI can assist, but only humans can make the critical decisions that shape that great products that affects our lives. So actually, yeah, AI will take some jobs. It will take over some routine coding tasks, but developers will still need to focus on the higher level skills. We will be the ones supervising AI. We will supervise AI if it really produces high quality, secure, and efficient code. The security is one of the main concerns of software. So we still need to supervise it if it really makes it's efficient and secure. So another part is AI integrations, right? We need to integrate AI together. AI's, we all talk about agents, etc. nowadays. So actually, agents should talk to each other, and we integrate that between integrate them between. So we will need to understand how to work with AI models rather than just writing every line of code ourselves. So, and problem solving, decision making, and AI ethics will be more critical. What to build, why to build, and if the AI is used responsibly. So it will be important. And we will be, as developers, we will be working at higher level, designing complex systems and driving innovation. Actually, still AI cannot do on its own. AI has big gaps right now. So and there will be for a long time, I believe. Well, actually, in short or mid-term, AI will not replace us, but the key is adapting. If you are writing code that AI already can do, it will replace you. Yeah, it's inevitable. So learning how to use AI tools, integrating them into your workflow, and focusing on the things AI can't do, like creativity, problem solving, and decision making. If you adapt to these, I believe AI will not replace you. But I don't see the future, so I'm not promising. So the real question is not will AI take my job, but I believe it's how can I use AI to be better at my job? Well, in short, developers need to adapt and evolve. We need to learn to work with it. If we deny that what AI is has become, so it I think it's a dangerous situation. So the future of software development is not about choosing between AI or humans. I think it's about how we use AI to become better developers. Actually, these all comments are subjective to me. So that's my opinion, So lately, the software development has changed. People are calling it vibe coding nowadays, right? If you are, following the Twitter X platform, and software development has become some kind of vibe coding. We actually it's not longer just about writing every line of code ourselves. It's all about telling AI what we need. Actually, we tell AI what to do, and it writes for kind of for the code for us, and we just supervise it, verify it, and accept if it's okay or not. Yeah, the skill set is actually shifting from just writing code to understand problems, defining solutions, and communicating with the AI, to make the processes efficient. So we don't want to write code. We just write we are just writing prompts to the AI tools. So there will be a skill, important skill, that how to write clear instructions to AI. And if we are good at instructing the AI, so we will be good developers, I believe. Well, the vibe coding feels like, take a break to it's like this. Sometimes I'm using cursor and windsurf bot, and sometimes it feels like that, but it's getting better and better every day. Well, let's talk about how LLMs help software development. Actually, we have some cases. I use ChatGPT on these slides, but there are loads of AI models and AI tools nowadays, so it will work. These will work, any of them, I believe. So the first case is writing code snippets faster, right? I believe you all know it and use it. Let's say writing a Python functions that counts the lines of the code in the given directory, separate file extension, and it wrote a Python function that works. Yeah. Sometimes it doesn't work in single shot, but it eventually writes after a couple of prompts. So the another case is debugging and providing suggestions for improvement. Yeah, actually, I want to make this code more functional, so it converts the old code to functional, approach. And actually, it's a hard task to do, most of the time. The third case, actually, there are many cases, but I will give some few examples. The third case is the writing unit test and integration test, which developers don't like. I don't see much people around that likes writing unit tests or integration tests. Nobody likes to write. So when I say write a unit test for the code, it simply writes, and most of the time it works, and it writes really well, by the way. Yeah, I'm using the GPT-4o model, but cloud is much better, I believe. Anyway, the fourth case is the explaining complex algorithms or concepts. I like this feature. Actually, not a feature, but this behavior. It can understand the previous developer's code, and I can ask what this code do, and it simply tells me what it does. I don't have to trace all the code with my bare eye. So let's see this example. When I first at the first look, I don't understand what it does, but when I just ask, it's simply sorry, I somehow lost the response. Yeah, anyway, it says it will reverse the string or array. Well, the fifth case is creating style guides, which I like. Actually, there are many MCPs nowadays around that connect to Figma, etc. But you can just share a screenshot, and it almost works. It works very close you have to tweak, but it works anyway. So it makes the huge part of it. So as a front-end developer nowadays, lately, so I spend my career as a front-end developer for a long time. So it was a huge task to do, but with LLMs, you can just ask and you get. Yeah, explaining language weirdnesses. For example, always make people make jokes about why quoted 2 plus the integer 1 is 21, and why the minus version of it is 1 in JavaScript. So when you ask it, it simply explains. You don't need to make fun on social media around about the JavaScript weird behaviors. So you can just ask. If you are a new learner, it will be better to ask to ChatGPT. It won't get bored from you. You can ask anytime. Yeah, let's talk about the tools. The fun part. The LLMs have limits, and AI companies started investing in tool calling to make AI more powerful. LLM got hit some limits, and it's instead of just relying on the model's internal knowledge, it has limits, and it's and immutable. So AI can now use external tools, APIs, and third-party services to enrich its output. This is where custom GPTs or model context protocols or etc. come in. So these things allow developers to integrate AI with external systems, databases, file systems, or the robotic arms, etc. Whatever you want, some real-world actions. In short, the AI is no longer just a chatbot. It's an interactive system that can do whatever you want, thanks to these smart integrations. So in this slide, I will build a simple ChatGPT custom GPT that connects to GitHub, and let's see how it goes. Yeah, you can, the MCPs lately are much more popular and easier to integrate. But to understand how it works behind, I will take the GitHub custom GPTs as example, and let's see how it goes. Yeah, when you create a new custom GPT, it will ask you instructions, conversation starters, description, and the name. Actually, as you can see in the instructions, you can write just prompts. As if you are using cursor rules nowadays, it's like cursor rules or windsurf rules. Yeah, you can just push some knowledge as embeddings. You can just upload some PDF files or some content. They will be embedding, so it will have more context what you do. And the custom actions actually the secret source of the tools. Actually, we connect tools using custom actions. So how the custom actions work is actually the answer is OpenAPI. OpenAPI is a specification for defining and documenting the APIs, as most of you actually know, I believe. So it looks something like that. It's if you are using the Swagger, you will have a OpenAPI spec. That's all. If you have Swagger, it's okay. You can tool your you call your Swagger from the OpenAPI custom GPT. So if you don't have any Swagger, but you have just API endpoints, you can just ask ChatGPT to generate the OpenAPI specs, and it's like almost correct. You may need to tweak a bit, but it's almost correct. So there's a few minor notes that you must use the version 3.1.0, and you must use operation ID in your endpoints. So actually, ChatGPT will know which function to call using the operation ID. That's one of the one important note. So let's connect GitHub with ChatGPT and try. Opening the developer settings on settings, and you'll create a new token. Actually, I created a classic token, and yeah, you can set an expiration and nodes, and you will give access to repo, and I also give access to workflow. Actually, that will help me to manage my deployments on GitHub Actions. So you will need to set authentication as a bearer API key that you will got from the API key generation on the GitHub. So you all done, and if you try on preview side of the action development, it will convert the prompts into requests, just as what we do in MCPs. And as you can see, it will throw some errors, and we will extend the the OpenAPI spec. So I tried committing a code from ChatGPT, and as you can see, I just wrote write hello world and commit to my AI repo, and it's hello world branch. So it's tried it, but as you can see, it couldn't do it because it says missing 3 object. So I asked ChatGPT how to handle this. I don't know, but it knows. So it says it needs to create a file, it needs to create a blob, modify the tree with the new blob, and create a commit. Well, that sounds like a good approach. So build the OpenAPI spec that builds it. We can't just import all the OpenAPI specs of GitHub API because it's huge, so it won't get all the OpenAPI spec. So you just need to select what you need. Actually, how do is blobs, trees, and commits, and I asked OpenAPI to do it, and if I need open a pull request, commenting issues, etc., it will add the endpoints. Yeah, actually, you simply change the custom instructions as you need. Change the OpenAPI specs as you need, and also you need to change the custom instructions as you need, just like in the cursor rules or went-source rules. This is one custom instruction example. Simply, I'm telling where to work, how to work, how I create PRs, etc. And also, you can connect Jira to, or other task managers. But I won't, repeat all the same stuff again to connect to Jira. But you can simply get this OpenAPI specs from this QR code, and also, I'm just speaking. You can pause and get the gist. Yeah, you can just use Jira and also OpenAPI. GitHub's endpoints you will need to do tasks. Well, let's make a Jira example. I have some kind of Kanban board And as a developer, I'm asking, okay, sorry. Yeah, I'm asking, what should I do today? Can you check? I connected my Jira, I'm connected my GitHub to ChatGPT, and I'm asking, what should I do today? Okay, and it connects to Jira and gets my tasks as writing a JQL and writes me down to what I'm on it. So, as a developer, I'm centralized all my work into a just chatbot. So as you can see, I can ask what's my teammates' expertise. I don't have to follow every person. What are they doing, etc. But I can ask, for example, one of my colleagues asked, what is Fatih's expertise according to tasks? And it says Fatih is building front-end and UX design stuff. And it simply can understand what I'm on it. Yeah, it's actually my dream is to generate the daily speech from my Jira tasks and the GitHub statuses, so I don't have to think what's my work. Well, you can do lots of things using Jira. Which tasks were reopened after being closed, and what are the durations between their closure and reopening? What is the list of blocked tasks? Who is blocking these tasks, and for what reasons? And what tasks have been pending for more than 3 months, and why are they still not completed? Actually, these are a bit complex stuff, but it tries to, and sometimes it works, but sometimes crashes, the LLMs for sure. But you get an insight. And how many tasks were added to scope after the current sprint started, and what could be the reasons for these additions, etc., etc. You need to be creative. Think about your routines, reduce them. For example, you can read your Confluence docs, and what you get. Actually, you can separate Jira tests, what you get from the Confluence, and write detailed acceptance criteria for each task. And other side, the code side, you can write test cases for the tasks, right? And when you write test cases, you can write code for them as well, and you can just open PRs for them as well. It's simple. Actually, you can connect Jira to LLM, GitHub to LLM, and you can just connect actually anything to anything. If you have an OpenAPI spec or MCPs, Cloud uses MCPs instead of OpenAPI specs. But anyway, you get the idea, right? You can now connect anything to anything using your LLM. So let's make a short demo. I hope it will work. Okay, yeah. Okay, and as you can see, I asked, can you please find the repeated code and reduce it on the code base, then open a PR? I'm on my iPhone. I'm using my iPhone. I'm not using my IDE. I'm not on the computer. Actually, maybe I'm driving or something. And I'm asking my project helper, custom GPT, to find the repeated code and reduce it to the code base, then open a PR. It tells me what to do first, and calls the API github.com. Yeah, it says it will now analyze these files to identify any repeated code, etc. it says there is index.js and test.js. So it wrote a refactoring plan, and it asked me to accept the what it will be. You know, on post request, it asks acceptance. So, well, it's find an issue and it created a PR. It's find an issue and fixed itself and created a PR. I'm opened the PR just a bit back. Well, I'm moving too fast. Well, it's actually removed my two functions. You know, as you can see, it removed my two separate functions into one. It's like padding left and padding right functions. There were padding left and padding right functions, but it removed both of them, and instead it created a pet cetera str function. So, and I'm asking, this is not right, you know. I'm asking keep the functions separate. Let's see how it goes. Yeah, it understand what I need and refactoring the code. Yeah, it's not writing on Turkish, sorry. But you understand the cases. Yeah, it's opened the PR with a PR, you know, comment, you know, it's right. It has a good PR title, has a good PR description. Let's see the commits. It even wrote the commit messages right, you know. Normally people don't. Well, let's read the code. Yeah, it seems it created a private function that called petstr, and it exported two different wrappers for them that reduced to repeated code. And you can see it also updated the tests. Yeah, that's nice. Let's merge the pull request and all done. Delete the branch. Yeah, as you can see, I'm tanking it because, you know, if it's you know, the AI takes over the world, I need to have some space to sorry him. Well, and you know, lately, actually for like 4 or 5 months, Cursor and Windsurf become a thing. Actually, this slides won't cover Cursor and Windsurf, but it's, you know, almost, you know, the same. You can just download the Cursor from the cursor.com and Windsurf from the Codium actually.com. Let's do some short demo with earlier version of Cursor to understand. You know, I think Cursor is too popular. I believe you all know how to use it. But as you can see, I'm asking it to create a CCLI that tool that counts and shows to-do items in a folder. You know, let's move fast. Yeah, it simply writes, you know, the old composer was like this. Actually, I like this UI more, but they've changed it anyway. As you can see, it creates the files as I need, and when I say accept all, yeah, it wrote. Yeah, I made it. Yeah, it works. Single shot works. You know, it's easy to handle, but anyway, it works. Yeah, let's make things harder. Sorry. Somehow I'm not. Yeah, let's make things harder. And I'm asking to, I don't know Rust. I don't have any idea how to write a Rust code. So I'll try to build a Rust project that connects to Pokemon API and questions the Pokemons by their name and gives some information about them. So as you can see, it writes some Rust code. Yeah. Actually, that's the fun part. I don't know how to run the Rust code. So it's when I say run project, it simply says it's a cargo run. Yeah, I didn't know that. So when I run it, it's actually the compilation part took more time from writing the code. So as you can see, actually it didn't work, and I asked Cursor to debug this code and fix it. So it tries find something and fixes the code. And again, there's another issue, and I'm asking again Cursor to fix it, and it finds the issue and writes the code. Actually, this is an earlier version of Cursor, so agent mode is not yet there. So when you enable agent mode, it's much more easier to, right now it's easier to handle this stuff and fix. Yeah, it's find another issue. But as you can see, it's 4 minutes. In 4 minutes, I'll have working, and let's see if it works. Yeah, search button is a bit off the screen, but anyway, it works, right? In 4 minutes, I just built a simple desktop application. So we need to bring them all together and use ChatGPT to ask questions or any other LLMs and create style guides, etc. Use ChatGPT custom actions or MCPs and to manage your custom workflow, get insights, or connect third-party APIs, etc. And you can use Cursor or Windsurf to write code and debug. Yeah, actually, we are developers. We can dream our own solution and find our solutions using the API AI tools. Yeah, that's all my slides. I hope you enjoyed it. Konstantinos, are you there?
Of course, I'm here and I'm listening very carefully. I was trying to understand whether someone is starting, would it be good for him to start with something like Cursor or Windsurf, or it will, make him a bad developer?
Yeah, actually, I believe if someone is starting from scratch, I
Yes,
believe they should start from writing prompts, writing good prompts. The everything starts with a good prompt. If you are not a
absolutely.
if you are not a writing, if you don't write good prompts, uh, you will have problems with using Cursor or Windsurf anyway. If
Yeah,
you can't tell what you need clearly and explicitly, so you will have issues on writing code, actually
anyways. Yeah,
making them write code. Yeah.
yeah, understood. Okay. I'm trying, to to see whether our audience, there are people that are very keen to start working on AI and they have not defined their clear path. And there are
Mhm.
questions that say, hey, where should I start from? Okay, I have used ChatGPT, I've used Claude, and I've used Gemini, but I want to build something. Should I do it step by step, like the old, new-fashioned way, or should I install something, throw the prompt, and let it create it from me, and then look into the code and start learning?
Yeah, actually, is the question step by step or at once, a single
Yes,
shot?
yes, yes.
Yeah,
Step by
actually,
step.
single. Yeah, actually, the answer is building step by step.
Yes,
Yeah, it's clearly the answer is like that. Actually, we should think LLMs, coding LLMs like kind of another developer, another junior developer, right? If you
exactly.
if you ask some junior developer to uh, you know build me a shopping site,
Yeah,
if it's a huge task to for them to
yes,
do. So
yes,
if you ask them, build okay, we will build a shopping site, but let's start with
yes,
registration and login. It
yes,
will grasp more easily and handle the tasks better and better. I
yes,
think we should behave the LLMs like is a junior developer.
yes, yes, yes. Well, that's great. Would you recommend Cursor or Windsurf? Or it's actually the same thing?
Yeah, actually, almost same nowadays. I started with Cursor, but
Yeah,
with the latest updates, the Windsurf become like this, almost the same. And actually, Windsurf has a better UX, I believe,
okay,
for the new starters. Actually,
okay,
non-tech people love to build stuff with Windsurf because this has a cleaner and understandable UI. Cursor is like a bit, tech stuff.
okay,
A bit. It has too many, tech jargon on it.
okay.
So yeah, it's the same stuff actually. I use both of them, and I'm building stuff with both of them. Konstantinos, are you there?
Yes, I have to say goodbye to you and
Okay.
thank you so much for being with us. Catch
Yeah,
up
I
with you
also
later. Thank you.
I also
Thank you, my
enjoyed
friend.
being here. Thank you very much, and I hope to see you again.
Bye
Bye.
bye, my friend. Bye bye.
Bye. Bye. Bye. Bye.
Yes, we are back with Tony Quinn. Uh, it's the first time that we are, how can I say that? We are collaborating, or we are having Tony with us. Uh, Tony will deliver the last session of the day for track two, and the name of the session is Voice AI Agents for SMB Operations. One of the most exciting parts of AI, right? Voice AI, how that can be uh, helpful for small businesses, and what are the how can I say, what are the main points that we should pay attention to, right? But I think Tony has more to say about that as our expert. Let me bring Tony in the stage. Hello, Tony. Hello, my friend.
Hello, Constantino.
I would like to thank you for being here with us tonight. We are so grateful that you are able to deliver your session with us. I will be on the backstage taking care of anything that you may need. You can write me on the private chat. And now you are on the driver's seat. You are the presenter.
Yeah, thank you so much for your invitation. Really glad to be here to share our experiences and some of the insights. And first of all, let me share my screen. I hope everybody can see my screen well.
Yes, we can see your screen perfectly.
Perfect. Yeah. So thank you for joining me today. And whichever time zone you are, it's morning here in the Silicon Valley. My name is Tony Chin, and I'm the co-founder and chief scientist at Forever.ai. We are a San Francisco Bay Area-based startup specialized in building conversational AI agentic systems tailored for SMBs. Today, I'll be sharing our insights and experience on designing task-driven conversational agents for business phone operations. A few where AI is making a transformative impact. Here's what I'll cover today. We'll start by exploring what makes conversational agents different from traditional chatbots. And then we'll delve into the key challenges encountered when we develop and deploy these agents in real-world scenarios. And next, we'll examine state-of-the-art techniques for aligning these agents with specific tasks. We'll also discuss evaluation methods to measure their performance effectively. And finally, I'll wrap up with a case study to illustrate practical applications and outcomes. Conversational agents, they're often mistaken for chatbots, but they serve a distinct purpose. While chatbots focus on general conversations, task-driven agents are designed specifically for task completion, from taking orders for restaurants to booking appointments for dental offices. These agents interact with an environment, leveraging structured inputs and outputs to navigate complex tasks. The key components of such agents are their ability to maintain state, tracking the context across interactions, and take meaningful actions based on input, and evaluate their success using rewards tied to task completion. So in this sense, they are of the same nature as reinforcement learning agents that a lot of us are already familiar with. And conversation here is just a vehicle for these agents to complete specific tasks. So before the rise of large language models, we had task-specific reinforcement learning agents achieving remarkable outcomes. For instance, rideshare dispatch systems optimize driver-rider matches using online reinforcement learning techniques, which I have worked on at both Lyft and Didi, the major rideshare platforms. AlphaGo revolutionized the board games by using self-play and Monte Carlo tree search and defeating world champions without prior human knowledge. And DeepQ networks for Atari games demonstrate human-level control. And so these examples all showcase how carefully designed learning algorithms are able to help machines achieve human or even superhuman level intelligence in specific domains. But none of them interacts with humans the way we do with each other. Why do conversational agents matter, right? The growing complexity of business operations, from managing customer support to scheduling, has made automation a necessity for businesses. Moreover, such automation requires human interactions. Task-driven agents go beyond generic chatbots. They provide domain-specific solution to real-world problems. For example, an AI agent in a restaurant can handle customer reservation, clarify menu details, and process takeout orders without any human interaction. Right. Such capabilities not only enhance efficiency but also improve user experience. Large language models have fundamentally transformed conversational agents. Traditionally, for customer service phone calls, we rely on static rule-based systems like the IVR, which is the interactive voice response systems, which are rigid and often pretty frustrating for users. Now, LLMs enable dynamic and adaptive agents capable of holding natural, completely open-ended conversations. And with superior language understanding than any prior NLP models, and the ability to generate contextually relevant responses, these agents are not only versatile, but also extensible to support continuous updates and task-specific adaptations. But all these exciting benefits don't come for free. As we'll see, there are a number of challenges unique to LLM-based conversational agents. So first, managing multi-turn conversations is one of the most critical challenges in building task-driven conversational agents. And unlike chatbots that responding to single-turn queries, task-driven agents must track context over multiple terms to ensure the business goals are met. So let's consider a restaurant reservation system. Imagine a customer calling to book a table. They provide the time and party size, but suddenly start to ask about parking options or dietary accommodations. The agent must not only address these side questions, but also ensure that the conversation circles back to collect all the mandatory information, right? Like a phone number or specific seating preference. And so this balance between flexibility and focus requires robust dialogue state tracking to maintain and update conversational goals dynamically. Unfortunately, most LLMs don't have inherent planning capabilities. They can generate coherent responses, but lack the structured reasoning needed to enforce such constraints. We'll go into details of dialogue state tracking later. Domain-specific terminologies, jargons, or even foreign item names, they can create significant barriers. For instance, a customer might order a banh mi, which is a Vietnamese sandwich, right? Or they can order a hago, which is a dim sum dish for in the Chinese cuisine, or ask for a taro ball, A general ASR model may not understand the first two at all, and can easily confuse the third one, the terrible, with the word terrible. And these are all from our first-hand experience in real-world conversations. Such transcription errors can derail the large language models in the conversation altogether. And to make such systems viable for adoption, business they demand extremely high accuracy and task success rates. The agent not only has to recognize these terms correctly, but also provide responses grounded in specific contexts of the query. Then there's an issue of hallucination, right? Where agents fabricate information. Imagine a restaurant agent allowing customers to order items not on the menu, or forcefully claiming ingredients in the dish, which is very dangerous for people with allergy. And worse, it might offer incentives like discounts that don't exist, so that undermines customer trust. This typically happens when the context lacks relevant data to ground the agent's response and prompt it to fill in the blanks with inaccurate information. Logical reasoning is another major hurdle for conversational agents. So let's break this down with some examples. Suppose you are building an agent to process orders at a pizza chain. The system must handle constraints like which crust types are available with specific sizes, or identify that a 3-piece taco order is a single meal and not 3 separate tacos. And temporal reasoning is equally critical. For example, lunch menu items might not be available until might be only available until 4 p.m. The agent needs to understand and enforce such rules without confusing the user. And basic mathematical tasks like summing up the totals of an order or applying discounts are straightforward to human beings or a calculator application, but often are not so much to a large language model due to how LLMs process data. In these cases, solutions involve hybrid systems where external rule engines or mathematical solvers can complement the large language model's capabilities to offer both flexibility and rigor. Now, a less obvious but foundational challenge is knowledge representation. For conversational agents to perform reliably, the way we structure business data, like product catalogs, restaurant menus, or schedules, has a profound impact on their ability to deliver accurate responses. So take an example again of a restaurant menu. A simple text list might not work for might work well for a small menu, but for larger menus with modifiers like size, toppings, or dietary preferences, more complex representations are required. Should the data be formatted as a hierarchical structure, a table, or even an annotated image? Each choice affects how well the agent understands and processes data. For instance, structured, context-rich representation often outperform linear, unstructured formats in terms of accuracy and relevance, according to studies in the literature. And research also shows that input format significantly influences the response quality of large language models. Factors like the order of your examples, the framing styles, or even the presence of irrelevant but semantically related inputs can skew outputs as well. So ultimately, the challenge is to design representations that not only align with the agent's capabilities, but also accommodate real-time updates, such as menu changes or inventory levels. Voice AI systems are usually latency critical. When users are interacting with a conversational agent over the phone, for example, even very slight delays can lead to user frustration. And business applications, especially in industries like customer support or food ordering, um, demand real-time responses, which makes latency a critical bottleneck. From the modeling perspective, the most capable LLMs often fail to meet these latency requirements. Their inference times are too high for fast-paced dialogues. And for example, even though the GPT-o1 model, the reasoning models have, or now o3, they have superior reasoning capabilities. It's not a feasible candidate for voice conversational agents due to its multi-step chain of thought involved in the inference time. And on the engineering side, streamlining the ASR LLM TTS pipeline, and by the way, ASR is automatic speech recognition, and TTS is the voice synthesis module. So this three-step pipeline is essential if adopting this traditional architecture for voice AI agentic system. And one promising direction involves speech-to-speech models, which bypass intermediate steps to deliver responses faster. However, without a dedicated ASR model, transcription accuracy remains a challenge, as we are still seeing in the GPT-4 real-time audio module. It also lacks the flexibility required in building an agentic workflow, where we need additional processing before having the agent to speak out the final response. Now let's talk about frontiers for aligning agents to the tasks that we have on hand. So to overcome some of the inherent limitations of LLMs, two powerful techniques have emerged and widely adopted. One is the supervised fine-tuning, and the other is the retrieval augmented generation, or RAG in short. Supervised fine-tuning involves training the model further on domain-specific datasets. For instance, an LLM fine-tuned on historical customer support transcripts will better understand common queries and the appropriate tone for responses. And this approach helps tailor general-purpose LLMs to specific business needs by aligning the model output behavior. RAG, the retrieval augmented generation, on the other hand, allows LLMs to dynamically pull information from external knowledge bases so that the system can assess the most current and relevant data. For example, inventory levels or the status of a food delivery, without requiring extensive retraining. And RAG bridges the gap between static pre-trained knowledge and the real-world operational requirements. So that makes it a common component in conversational agents. And improving the robustness of transcription system is another critical step. So we mentioned a few examples about the common challenges in transcribing jargons or domain-specific terminology or foreign food item names. These are the challenges that we need to overcome in robustifying the transcription system. Fine-tuning the ASR models on domain-specific audio, such as customer interactions in a particular language or accent or background setting, like in the case of a drive-through, right? They can significantly enhance performance on challenging words or basically coping with the kind of background noise that you would encounter. For the ease of end user adoption, some commercial ASR models have supported self-serve customization to allow users to supply keywords or key terms for the model to pay more attention to some specific words through API parameters. Now, to fight hallucination on task-driven agents, several strategies have emerged to be valuable to have in our toolbox. First is the to fine-tuning the models. So by training on high-quality curated data, the LLM models develop stronger understanding of the relevant knowledge and reduce their tendency to fabricate responses. For example, a fine-tuned restaurant phone agent is less likely to invent a menu item or give out incorrect pricing. And second, RAG equips agents with the ability to dynamically access external knowledge bases during inference time. So instead of generating unsupported answers, the model retrieves accurate, up-to-date information, such as inventory levels or promotional offers of the day. And this greatly reduces the risk of hallucination, particularly in domains where data changes fairly frequently. And third, on the better foundational models usually reduce hallucination out of the box. Right. And finally, with chain of thought prompting, the model evaluates its reasoning through multiple steps before finalizing a response. For instance, instead of guessing a substitution for an unavailable menu item, the model might explicitly outline the recommendation and verification steps, which lead to a more reliable response. And earlier on, I mentioned dialogue state tracking when I was talking about the challenge of multi-turn conversations. So dialogue state tracking, DST in short, it improves conversational agents' planning capabilities. Its purpose is to maintain a coherent agent state by tracking user intents, slot values, and context across multiple turns of interactions. Without robust DST, agents risk losing track of critical details, and then that often leads to frustrating user experiences. Basically, you can imagine an agent suddenly forgets what you have been talking to it a few seconds ago. All right, that could lead to a very frustrating experience. Now, consider a restaurant agent handling a reservation. The DST ensures the agent collects the required information, such as date and time and party size, and while also accommodating optional inputs like dietary preferences, and maintaining this state across interruptions or follow-up queries are essential for the completion of the task. And emergent approaches like chain of thought explanation for DST take this a step further. So by breaking down decisions into interpretable reason steps, model improve coherence and accuracy. So for example, when a user modifies their reservation, chain of thought reasoning ensures all affected details are updated systematically. And we talked about LLM's deficiency in planning capabilities. Here, the LLM modular framework uses LLMs to support external planning systems rather than relying solely on them. So in a modular framework, LLMs handle language understanding and candidate plan generation, while external tools manage structured reasoning and decision making. So this hybrid approach leverages the strengths of each component to deliver more reliable solutions instead of ascribing LLMs to do something it's not good at by nature. And beyond generating natural languages, task-driven agents often require advanced reasoning and decision-making capabilities. This is where search and planning techniques such as the Monte Carlo tree search come into play in post-training compute. MCTS has been instrumental in applications like game playing AI, but its potential extends to LLM and conversational agents by enhancing the model capability and enable agents to self-improve. In addition, integrating LLMs with traditional optimization tools is also a powerful approach. For example, scheduling appointments or managing inventory levels involve well-established operation research algorithms. I myself come from an OR background. So there are well-known OR algorithms that that can do those tasks. So combining the LLMs with established domain-specific algorithms can complement the generative capabilities of LLM, and then as a result, we create hybrid systems that are both flexible and precise. On data representation, as we discussed earlier, the way information is structured has a profound impact on how effectively an agent can understand and respond to user queries. So multi-model models like GPT-4o and Gemini integrate text and visual data. Right? Imagine a customer asking about a dish. An agent with multi-model capability could refer to both a textual description and an image of the item for richer, for more accurate responses. And it's also possible to improve reasoning and retrieval by encoding structured business data into meaningful embeddings. For example, sentence transformers can map menu items into a semantic space and enables the agents to make connections between the related concepts or handle ambiguous queries more effectively. And ultimately, experimentation is key. So business must evaluate different data formats, be it linear, hierarchical, or multimodal, to find what works best for their operations. And to address the challenge of latency, the voice AI stack has been evolved quite significantly, moving from traditional, I mentioned the ASR, LLM, and TTS three-step pipelines to more advanced architectures. Traditional pipelines involve separate components, three separate components for recognizing speech, for generating the dialogue responses, and for synthesizing them back into audio. So they are effective. These pipelines can introduce latency and complexity if not optimized. So in this regard, DeepGram and 11 Labs have been working pretty hard on this architecture to deliver agent API with latency low enough to meet the requirements of the real-time voice agents. And recently, Andrew N talked about a pre-response technique for mitigating perceived latency. So the main idea is to have the agent say some bridging words while its large language model is taking more time thinking and coming up with the final response. So this significantly improves the so-called perceived latency, basically the latency that we human feel, but actually it's still the latency. The actual latency is still there. It's just that it makes us feel that it's not as slow, right? And there are also newer frameworks like the I also mentioned in the previous slide, the real-time APIs offered by OpenAI. They enable speech-to-speech processing, so that naturally reduces the latency, and also having the advantage of being able to understand audio tone or expressions, which are not transcribed into text. And inference optimization is another key focus area. By leveraging hardware acceleration and frameworks like TPU and Grok, we can achieve significant performance gains, and that makes the voice AI agents more responsive and scalable for business applications. A prerequisite for improving agent performance is the ability to evaluate. Though evaluating conversational agents requires a fundamentally different approach from traditional LLM benchmarking. While the LLM benchmarks often focus on single-turn tasks like question answering or summarization using metrics like MMLU and the truthful QA, agent evaluation must account for multi-turn interactions. So that's a key difference. And in multi-turn conversations, performance hinges on maintaining context, achieving task goal, and ensuring a smooth user experience. Metrics like task completion rate and dialogue success rate are vital here. For example, in a restaurant scenario, the TCR measures whether the agent successfully captures all necessary details to complete an order. And DSR evaluates how seamlessly the interaction flows, including whether misunderstandings are resolved effectively. And there are other custom metrics tailored to applications, include measuring efficiency through average handling time. On average, like how much time the agent needs to spend on resolve a customer request, or error recovery rates. How often that you can actually recover from your own mistakes during the conversation. Another key difference is the role of user sentiment and satisfaction. Unlike static LLM tasks, agent interactions directly impact customers' perceptions. So metrics like customer satisfaction score or sentiment analysis provide insight into how users feel about their interactions. And that adds an important additional human-centered dimension to our evaluation. For complex subjective tasks, human in the loop evaluation is critical. Automated metrics alone cannot capture the nuances of whether agent accurately interprets user intent, especially for ambiguous or edge case queries. Take the example of a customer making a special request for a food order. Human raters play a critical role in verifying whether the agent correctly understands and implemented the request. And human feedback is particularly valuable in defining agent behavior. By feeding evaluator insights back into the training process, we can improve accuracy and robustness over time. For instance, frequent errors can be flagged by raters, and they can highlight gaps in the training data or model logic, and allow more targeted updates. And scalability is still a challenge. So balancing between manual evaluation and automated metrics is pretty crucial, especially for high volume deployments. So one could leverage tools that streamline this process by providing platforms for structured annotation and assessment. An additional challenge involves training raters to maintain a consistency and handle subjective tasks. And for more automation, a popular technique is an LLM as a judge to build agent to evaluate another agent's output. But as a research experiment has shown, we need to be aware of the reliability issue of such technique. Although it's argued that verifying a task completion is much easier than completing the task itself. There's no guarantee that self-correction, if you do self-evaluation and then correct yourself, there's no guarantee that this will always lead to the right answer. So we've seen numerous cases firsthand where you may change the correct output into incorrect ones. After figuring out agent evaluation, we can develop a continual learning framework. Continual learning is essential for this kind of task-driven conversational agents to remain relevant in a dynamic environment. So unlike traditional models that are trained once and deployed, continual learning enables agents to adapt to new tasks, new domains, or changing user needs without having to completely retraining. One key technique here is reinforcement learning. Not surprisingly, so RL allows agents to refine their behavior based on reward signals tied to specific goals, such as maximizing customer satisfaction or reducing average handling time. For example, the RL trained agent might learn to prioritize clarifying the ambiguous queries early in the conversation to avoid user frustration later, right? But challenges still remain, such as designing meaningful reward functions for multi-turn interactions for reinforcement learning and to ensure stable training on large-scale models. And self-play is another important technique in reinforcement learning to generate additional experiences. And in this method, agents simulate conversations with themselves. And it's a pretty natural thing to do. You can since it's a large language model, you can design the model to basically to talk among itself. And agents then evaluate conversations with themselves, and they explore various edge cases and improve their responses through iterative feedback. And this is particularly valuable for conversational agents, where edge scenarios can be pretty difficult to capture in pre-existing data sets. And continual learning also benefits from human feedbacks, where human evaluators guide the model's adaptation by explicitly flagging those errors or providing corrections. And with the experience and feedback, we then need to update the LLMs. There are frameworks like low-rank adaptation, the LoRA. They allow efficient updates. So instead of retraining the entire model, LoRA fine-tunes a subset of parameters that significantly reduces the computational costs. And this is ideal for scenarios where agents need frequent updates, such as incorporating seasonal promotions or new product lines. And recently, we've also seen a pretty exciting new methods of reinforcement fine-tuning that tries to align model on performance instead of behavior, which is what the supervised fine-tuning does. Now let's look at a case study. We have talked a lot about the challenges, how we can use various techniques to align to tasks and evaluation methods. So here we look at a concrete example on customer service automation. So this system provides multi-channel support over phone, mobile apps, or websites, whichever makes it accessible to the customer, or whichever they prefers to engage. And beyond simple automations like resetting passwords or explaining bills, the system leverages user data to offer personalized recommendations, such as better service plans based on a specific user's usage history. And for sensitive or complex issues, it escalates a call to human agents to prevent unnecessarily long calls. So human in the loop is still important for this kind of agents. Metrics like task completion rate, average handling time, and customer satisfaction score, we talked about that before. They offer a very clear picture of the agent's performance in terms of their quality of handling the calls and requests, and how efficient they are in resolving those issues, right? And how is the conversational goals in terms of customer sentiment. So I'll close by mentioning two areas that I believe would continue to stand out in the future. First, multimodal agents are set to redefine conversational agents by integrating text, speech, and even visual inputs. Imagine an agent that not only answers questions, but also display images of menu items or troubleshooting diagrams during interactions that offers the next level user experience as well as agent capabilities. And second, continued learning ensures that agents improve themselves within a complete feedback loop and remains relevant in dynamic business environments. So I expect it remain the central research topic for agent success as conversational agents become more and more ubiquitous. As the scale of deployment increases, the ability to continually improve based on new interactions data without much human intervention becomes even more critical. So this is a list of some of the literature references that I mentioned during the talk, and I'll stop here. I put up my contact information on the slides, as well as a live demo phone number that you can call to get a sense about a conversational agent for restaurant phone operations. Thanks for being with me, and happy to take any questions.
Great. Thank you so much, Tony. Let me see if we have any questions here. No. If I catch that correctly, are you calling from the US?
Yeah, I'm based out of the San Francisco Bay Area.
All right, great. Okay, thank you for posting your info here. We are going to definitely connect with you. One of the best presentations we've seen so far. I don't want to say others were not that good. Every presentation is amazing. I liked especially this one for Tony's style of delivering and the way he approached his team. I'm going to definitely watch it again. Remember, everyone, we can watch all the presentations in our YouTube channel. So I know we have around 40 sessions in this event, so you can watch them in your own time, like this one by Tony Quinn. Thank you, Tony, again. We are so
Thank you.
grateful you could be with us. Have a great day.
You too.
Bye bye.
Yeah, bye.
Bye bye, my friend. Yeah, and that's it. We are about to wrap it up for today. Azure AI Connect, day 4. We are coming closely to our end of our 5 days event. Tomorrow is the last day. Let me see if I can show you it real quick, our schedule for tomorrow before we say good night. Good night for us, since I'm calling from Greece and it's almost 8. It's 25 to 8. So I'm going to show you my window with our schedule for tomorrow. So yes, tomorrow we have data-centric AI accelerating success with Apache Iceberg data products with Andrew and demystifying AI, unlocking transparency with explainable AI. Very interesting. I don't know if Manai will be here. Build low latency AI voice agents using real-time GPT models. Also interesting with Milan. Enhanced document processing with Azure OpenAI and Azure Search with Pavitra. Innovation with Azure AI from LLMs to cognitive services with Rohit. Introduction to Microsoft Fabric data analytics for the era of AI. One of my favorite ones with Javier Villegas. Javier has been with us since the very beginning of our community. And I have to say, Javier is one of the most recognized data engineers, data architects, and uh, you know, now AI, of course. I'm just want to say Javier is always welcome and he's always delivering very, very interesting sessions. Uh, Five models, innovation in small language models for efficient language processing with Luis, and semantic kernel, redefining C# development with AI-driven solutions by Elon. I have to say, in our 5 days of Azure AI Connect, we had almost 45 speakers with 45 sessions. Okay. Now, the reality, the reality is that we were able to deliver, and I mean able, uh, because we are people and things happen. So far, we have not been able to deliver one, two, three, four, five, six, seven. Let me recount. It's almost a little bit late. One, two, three, four, five, six, seven. Yeah, 7 sessions out of about 30. Okay, about 32, something like that. So I believe it's a good number. We are in a very good position to say that this event is going to be a success. Now, we didn't have that much of live viewers, okay? And I can understand that. Not everyone has the time to be live and watch their session and their favorite speaker or their favorite theme. But we are noticing that people are watching on demand, and this is very important. Together with Azure developer community Tamil Nadu, I'm sorry, Tamil Nadu, we have gone this route with live streaming with StreamYard and also on demand, the capability to offer on demand viewing on YouTube and LinkedIn. I know that YouTube is what people prefer, and this is what we are seeing. We are seeing a lot of on-demand viewing on YouTube. So I want to thank you guys for supporting our communities and our channel. I hope you are liking the sessions. Forgive us for any minor mistakes we may have done, but it's always on goodwill. We are trying to be there for everyone and deliver the best experience for speakers, for attendees, and for us, the moderators and the team. So I'm going to play our outro and see you tomorrow. Have a great one. Bye bye from me.